So as we start lesson 4.4, proportional and non-proportional situations, this is more of a review. They're going to present to us some situations like graphs, equations, and you determine if it's going to be a proportional problem or a non-proportional problem. Okay, so in this situation, if they give us a graph and they want us to look at this graph and tell if it's going to be proportional or non-proportional. So if you have a line that is straight, because the lines are straight by definition, it's going to be linear. So it's definitely linear. But is it proportional or non-proportional? So to tell, you look at the origin. If your line touches the origin, it's proportional. So the graph shows a linear proportional relationship because it is a line that contains the origin. So a linear proportional relationship because it is a line that contains the origin. If I write it in there, it's just too small for me to write, so that's what it's supposed to be. Okay, so on this your turn, they want you to determine if it's proportional or non-proportional. So just look at the graph and see where they touch and see if they go through the origin. I'll give you a few seconds for this. Okay, so the first one does not start at the origin, does not touch the origin. So this is non-proportional. The second one does touch the origin. The second one is proportional. Okay, now we're going to distinguish between proportional and non-proportional situations using an equation. So this is the mathematical terms to figure out exactly what they're talking about, but I'd rather show it to you this way. So if something is proportional, the equation is going to look something like this: y equals mx. If it's non-proportional, it'll look like this: y equals mx plus b. You see on the first equation, there's nothing being added on to the end. There's no y-intercept. So it's automatically a 0. So that means that when you graph this, you go through the origin. If your equation looks like this, there's something added on to the end. That means that some place other than the origin is where your graph is going to start. So if we pretend that this is a -2, your graph is going to touch the origin, or excuse me, touch -2 here on the axis. Whereas because there's nothing added on to the end of the first one, it'll go through the origin. Now what you have to be very careful of is you have to make sure you have 1, 2 variables in your equation. 1, 2 variables in your equation. Okay? You'll see that when we have to do some problems. Okay, so here's a problem with Keith. Keith graduated from middle school. The number of years can be represented by y equals a minus 14. Now, this is going to be the number of years since he graduated middle school, and a is going to be his age. So his age minus 14 will be how many years ago he graduated middle school. So y equals a minus 14 is going to be the equation we're using. This is in the form of y equals mx plus b. The plus b is right here, the -14. So if we were to graph this, we would start at -14 on the y-axis. The slope is 1. Remember, any variable can have a 1 in front of it, so the slope is going to be 1. So you rise 1, run 1. Rise 1, run 1. Okay? So what they want to do here, it says in a proportional relationship, the ratio y over x, remember that's your constant of proportionality. So if you have proportion, you have a constant of proportionality. Show that this ratio is not constant for the equation y equals a minus 14. So what you do here, and you don't really know to do this unless you see it once, just pick some values for a. So if I let A equal 16, then y is going to equal, well, it would be 16 minus 14, y would be 2. And then if I try a different one, I'm going to let A equal 20 and calculate y. So if A is 20, y minus 14 would give me, A minus 14 would give me 6. So this would be 6. We have to make our y over x. We have no numbers to use for that. So I made my own y and x. This is the same as x. My y and my x, my y and my x. So let's take these and find our constants. So 2 divided by 16 is 1/8. 6 divided by 20 is going to be 3/10. Now you can see that the constant proportionality doesn't work here. So it's not constant, therefore it's not proportional. So that's how we can show that the ratio, there's our ratio, is not constant for the equation. It's not constant. You pick any value of A, plug it in, find your Y. Do that twice, and they don't match, so you're good. So next says, what if you have another equation that represents Keith's age in months, Y, given his age in years, A. Is this relationship proportional? Explain. So that equation would look something like this. Y would equal 12A. So whenever I know his age, A, let's say he's 10 years old. So if he's 10 years old, Y would equal 120. So if he's 10 years old, he'd be alive 120 months. So this would be proportional because there's nothing to be added on to the end. Nothing added, nothing subtracted. So this equation would be proportional. Okay, here we are at the your turn. You have 5, 6, 7, 8. You tell me proportional or non-proportional. I'll give you a couple minutes here. Well, a couple seconds here. So that's me, my shortcut. So I look at this first one, D equals 65T. I do have two variables, and there's nothing added on to the end. So this is going to be proportional. So I put proportional. That's my shortcut. Then here we have something being added on to the end, so this is not proportional. Here I have the equation on number 7, but I can always rewrite that if you need to look at it a different way. I can just switch the 3p and the 450 around, and I make sure that that's a negative 3p. So this wouldn't be non-proportional because it has the plus 450 at the end. And 8, when you first look at 8, you think 8 is also proportional, but actually it is not. You only have one variable here. You need to have two variables. Okay, this time we'll be using a table to see if it's proportional or non-proportional. Remember that it's proportional if the quotient, if the ratio of each pair of numbers is constant. That means there's a constant of proportionality. Okay, so this is a coin. It's called a peso, and a peso is our equivalent of $1. So whenever we go to different countries, they have different monetary amounts. So you trade money. You give them, it says in this little situation, the American tourists gave them $130, and then the bank in Mexico gave them back 1,690 pesos because that was the exchange rate. So US dollars are very strong in Mexico. So you take your y, divide by x, your y, divide by x, your y, divide by x. You can see they did that for each of those pairs. They're a constant, and so this would be a proportional relationship. Here are the your turn problems. Figure out if these are proportional or non-proportional. So y divided by x, same thing, and now they have to be the same to be proportional. Okay, so I did 30 divided by 2, which is 15. 90 divided by 8, I could get it down to 45/4. They're not the same, so this is going to be non-proportional, which I didn't write in yet. There's no reason to check the last one. The first two don't match, you're done. On problem number 10, 1 divided by 5, 1/5. 8 divided by 40 is 1/5. 13 divided by 65 is 1/5. I would not go to decimals on these all the time. Some of the decimals won't work out very nice. They won't be, this is 2/10. They won't work out so nicely. They might be very long decimals, but they're all the same, very long decimal. Keep it as a fraction. There's no reason why you need to change it to a decimal. Okay, so we have some real world situations. Determine if they're proportional or non-proportional. Okay. Okay, so first we have a laser tag, and the league has 2 arenas that they're going to use for a tournament. In both cases, X is the number of hours they would rent the arena, and Y is the total charge. Compare and contrast these two situations. So arena A, we can say that this is proportional. Doesn't have the plus something or the minus something on here. We know that this number, this is the slope. X is the number of hours, and they're going to charge $225 for every hour, but there's no extra fees. On arena B, this graph does not start at the origin. It actually starts at 50. So at 0 hours, you're paying $50. So there's actually a fee associated with this problem. So if you go to the arena B, for 0 hours, you're paying $50. And then that you see they have quarter hour, a half hour, 3/4 of an hour, 1 hour. So for 1 hour, they're charging $225. Excuse me, $250. So they have a fee, plus they're charging more per hour. So those are things that you can say about these two graphs, and you can read here also. We would say this is non-proportional. Okay, here's a second situation. This is Jessica. She's going to hire some painters. Painter A. So this is the number of hours they would work, and this is how much that she's going to have to pay. They charge $45 per hour. I would rather they don't have the dollar sign in here. We don't put symbols like this into our equations. Here we have Painter B as a table. So in Painter B as a table, to figure out what the heck's going on, this is proportional or non-proportional. Well, one way you can look at it is X is 0. To be proportional, if X is 0, Y has to be 0, and it is not. So this is not proportional. Let me show you, if you are going to graph this for Painter B, your line at $0, your line would start up here at the 20. That's where you'd start your graph. So at 0 hours, they're having you pay $20. That must be just like a fee or something. And then they also have their hourly rate. So for 1 hour, it's $55. Well, take 55, they're charging you for an hour. Take off the 20, that's their fee. So they're charging you $35 an hour. So they're charging you less per hour, but they do have a $20 fee. All right, and here's a your turn. So we have Test Prep Center A, Test Prep Center B. There's some information about each, and you have to compare, contrast. Same idea. Just tell me if they're proportional or non-proportional, things like that. Okay, since it's kind of difficult for me to write on these little lines, I just kind of made a little chart thing, but I'd rather have you make real sentences. So I said that this was proportional. You can see there's nothing being added on to the end. This one's not proportional because it's going to charge you 25, but you get a $100 coupon. So it's going to be C equals 25H minus $100. So it's almost like the first 4 hours are free because you get the first 4 hours, it's $100. Well, 25 times 4 is 100. There's a coupon to save $100, and they don't have anything like that. Here, the rate is $20 an hour. This rate is $25 an hour. So Center B charges you more per hour, but they do give you $100 savings. Okay, so they want you to see if proportional or non-proportional. It says look at the origin. So the first one I see here, oh, this is the guided practice. So the first one I see here, it looks to me like it goes through the origin. So I'm going to say this one's proportional. You write out the whole word. This one does not go through the origin. So this is non-proportional. You write out the whole word. Okay, so these two, you want to see if these are proportional or non-proportional. So what I noticed first here about this first problem, since I'm adding something onto the end, this is going to be non-proportional. Nothing being added on here, this is proportional. All right, so use your tables here. Remember y divided by x, y divided by x on both of them. So it says find the quotient. You're finding that ratio. So find the ratio and tell me if they're proportional or non. Okay, so if I divide y by x on these, I did that up here in blue. They're 4 each time, so they're proportional. And that's my constant of proportionality. So I divide 4 by 22, and I can go to 2 11ths. See, I would put that as a fraction, or excuse me, as a decimal, because that'll be non-repeating decimal. 8 divided by 46, I reduce this 4 23rds. These do not match. No reason to check the last one. If the first two don't match, it won't make a difference. So non-proportional. Okay, on number 7, so you want to see if this is proportional or not. It is linear. They tell us it's linear right here. Describe it in other ways. So just to tell if it's proportional or not. So here's your y, divide by your x. Here's your y, divide by your x. Here's your y, divide by your x. Okay, so I would say this wasn't the easiest problem to do, but if you kept it as a fraction, 12 over 15 million, 16 over 20 million, 20 over 25 million, they all equaled 1 over 1,250,000. If you went and did this with a calculator and converted it into a decimal, they're all equal this. So this is tenths, hundreds, thousands, 10,000s, 100,000s, 100,000s, 100,000s. So I wouldn't really want to have to read this number. If this is your fraction, this is your decimal. Make sure that the little number goes in first, and these would be the same, which way you did it, and so they're proportional.